What's up guys, Shane here from Fugatech 3D Printing, and today we're going to 3D print a watch winder for an automatic watch. Welcome back guys. So yes, today we are going to 3D print a watch winder, and more specifically a gyroscopic or a gyro watch winder, which basically is going to twist our automatic watch in all kinds of crazy cool ways, kind of like an awesome display case, and it's going to keep it wound. Now that's the kind of the big problem with automatic watches. If you don't wear these every single day, they die because you have to either wind the spring inside by hand, or you have to wear it and there's a pendulum inside that rotates, and that's what charges the capacitor, battery, whatever it is that makes this magic sauce work, is that pendulum in there that you can feel as you twist your watch around. So I have been wanting to make one of these for such an absolute long time. I've had this watch for probably about 4 years now, and every single time I wear it, I need to pull it out, I need to wind it up, and remember to do so. All right, well, before I jump into my little bin of parts and electronics here, let's talk about today's sponsor, and it is Cults 3D. Yes, Cults, the online website where you can upload free items, or you as a creator can upload them and sell them on their website to run your 3D printing business. They contacted me several months ago actually, and I had kind of gotten a list together of projects that I really wanted to do that were either free or required money on there, and they said, hey, well, give us a list and we'll let you know. So this is the first one that I decided to actually move forward with. I emailed them just a few days ago to get this really rolling, and this watch winder is going to be an awesome project. So expect more from them in upcoming videos, and I want to say thank you to Cults for making this possible and allowing me to make this content. And if you want to know how you guys can get this STL free of charge, make sure you check the video description. I'll have all the details down there. It's only limited for a few people, because obviously they're paying the creator of this file to give it to you, but you can get it free of charge. All the details will be down below. Okay, so I decided to print this in a few different colors, well, technically two. I wanted like a steampunk kind of look, but I don't really have any copper filament left, so I ended up using this brass filament that I got from, I think it was from Fry's. They had it on like some stupid sale. It's a 500 gram spool, and it was maybe like $6 or $7, really on dirt cheap sale. So I picked it up. It looks decent. I really wish it was copper, but we're gonna make brass work out just fine. And I'm using some black PLA here, so electronics, we'll get to that. All right, so we're gonna need to make this possible. We're gonna need an assortment of M3 nuts. We're gonna need some M3 bolts. Specifically in his documentation, it says you need 8mm and 12mm. I did notice that I'm using a 20, I believe. Yes, I'm using a 20mm on the main locking piece. So this is where your watch is gonna go on. You're gonna expand it so that it stays on there nice and tight. I found a 20mm work best on there, but you're gonna need 8 and 12mm for this, a bunch of the nuts, and all these 3D printed parts. The nice thing about this model versus all the free ones or other ones that I found online, this one does not require any bearings. So basically there's enough tolerance within the parts, and he also has some offsets on here. And it's PLA, so PLA against PLA is pretty good, especially at these very low speeds. The friction is very low, so they run very smoothly across each other, and you don't have to crank it down really tight. It's not going to come undone because of the way that it is, which again, very interesting to see. I really do like this design, and that's why I chose to make it. It is the easiest one out there, so well, we'll see, because I'm going to show you how to make it. All right, so let's go over the electronics first. He provides a schematic on his page that tells you exactly what you're going to need, and you can use different Arduinos for this, but I have this kind of prototyped up here. So here I have my mess of prototypeness, and I'm using just a very, very small Arduino Nano. I believe these are maybe $1 or $1.50 on AliExpress. I bought maybe 10 of them because they were just so cheap, and I wanted to have some in. I think it was a pack of 10 actually for maybe a few dollars. So I have a bunch of those that were really good to have. You're going to need this specific stepper driver and this small stepper motor. which this is a, what is this one called? It's a 28BYJ48. It's 5-volt little stepper motor, very silent. And again, we're doing this very low speeds. I mean, all in all, the electronics needed for this is just a few dollars, but they're very easy to get online. And we're gonna need a 5-volt power switch. Now this one is one with a blue power button, and this is an on-off, it's not a momentary. So when we push it in, it stays in, it'll glow. When you unpress it, it will turn off. So it's very nice. I mocked up the wiring for this one. This I did not actually wire into my schematic because it's a little hard for me to figure out switches. I'm not very good at them. But you can use pretty much any type of just small DC 12-volt DC power switch. Will work out just fine. This is a 16 millimeter, and that is what fits inside of this opening in the front. One of the differences I did make to this, and I didn't model it in, I just used a drill. So I have these wee little DC sockets, and what these are is literally it's just a little plastic socket for a DC barrel plug that you would get on any 5 or 12 volt DC wall wart. And I just drilled and I put that in there, and it's so tight it stays in there. I am going to add a little bit of hot glue around it just to be sure that it stays in there. For me, I wanted to be able to plug in a power supply and unplug it. So I actually could modify one of these to work off a USB or something like that. That's kind of what I wanted to have. I did not want to use anything else. I could just cut this off and just cut a USB cable and hardwire it right into the switch. You can do that as well, but I have these power bricks and I have these barrels, so that's what I'm going to use. It just works out better for me. Now, I know these electronics look like a lot, and I am definitely not an Arduino person. I am not an electronics person. Well, I guess I do a lot of 3D printing, but like things like this, I figure out, I muddle through. It's really, really not that difficult. I'm going to show you up nice and close what this all looks like. All right, so here we have everything. I'm just using this prototype board here just in order to make it a little bit easier to test out. This again was a few dollars on AliExpress. I like having it so I can try and learn how to prototype different things. And this is not even the proper way to do it because I'm using these jumpers and whatnot. But either way, it helps me get power into this, to my LED, and then into my little Arduino Nano here. And as you can see, we're using pins 8, 9, 10, and 11, which is hooking up to the actual stepper driver here. The stepper driver has a positive and negative coming off of it, which is going back to the 5-volt rail. These will actually connect to the 5-volt switch. And on this little driver board is our motor is connected to that. I added a little piece of tape on there so that I can see the rotations. The sketch that I'm using is different than what he called for, and I will put a link for that down in the video description to my GitHub where you can download it. And what it is, it will rotate this motor 30 times, 15 in one direction, 15 in another direction, then it will sleep for an hour, and then it will rerun the sketch. So it's very, very simple, and I mucked 2 different ones I found online together to make one that I liked. And again, super simple to do. It uploads to this without a problem. This is with the one with an old bootloader is how it is in Arduino IDE. Very easy to upload. So if you have any questions on it, leave me a comment down below or on the GitHub, but you should be able to do that without a problem. Again, I'm also just using this, this is labeled for Arduino Uno. It's a little 5-volt plug. It's 5 volts, 2 amps. So very, very small amperage, very small power supply. I have this for my electronics projects. I have several of these in my little bin. So I'm going to be using one just for this. Again, you could modify a USB cable because off a USB wall wart, you're going to be getting 5 volts. You can just cut the end of that off, find your positive and negative, and solder that directly to the power switch. I just chose not to do that. Okay, now let's actually get into the parts here, and we're gonna have to do a little bit of prep work in the beginning because we're going to have to press fit quite a lot of M3s. And how you do a press fit is you're gonna get an M3. All right, so this one here we can see, so on the back here we have what's the cutout for our actual hex nut, and then on the front it's just a round circle. So we're gonna go ahead and put our bolt through. We're going to grab a nut. We're gonna go ahead and just thread that in there. I like using these larger head M3s. We're going to be using pan heads for this, as that's what's required, but these larger ones are fine, so easier to turn. And we're going to go ahead and line up our bolt in there, and then we are just going to crank it in to where it belongs, where it fits in there. Once that's in there all the way, then we can go ahead and back out our bolt, and that is stuck in there, and that is how you press fit an M3 or any type of actual nut into a 3D printed part. That's the best way to do it right there. There's a few other spots on these which are just take an M3 and they actually just get slid right in. They will be signified with a slit and those just press in there like so. And you're just going to use your screwdriver to go ahead and just line that up so that you can see into the hole through the nut that's in there, and that's set up. So it's, again, very easy to do, but I'm going to go ahead and do all of mine real quick and then we'll get back with the assembly. All right, so now that all of these have those nuts press fit into all the pieces, we're going to go ahead and get out our button head M3 12mm length bolts. These are what we're going to use for the majority of the build, and we're going to go ahead and put all of this together. So go ahead and watch this time lapse. Try to keep it not too fast so you can watch the process. If you have any questions, again, leave a comment down below. right, so wiring that took about 20 minutes. I did have an issue with the power button here in the front. The hole was not big enough for my switch, just by like a little bit. So I ended up just putting a piece of sandpaper on my little drill here and running that through it for a few minutes, and I was able to get that down enough to fit. I did start with a needle file that didn't work, so make sure you check yours before you put it together. I dry run almost everything else, or dry ran. I did not dry fit this before I actually was installing it, so you know, you live and you learn. So I think that's all correctly wired. We're gonna plug this in now and see what happens. All right, so if I wire this correctly, we should be able to plug our power in and then hit that button. And there it goes. Look at that. Oh my goodness. Look at that go. Oh my God. It's mesmerizing, isn't it? Just watch that. Man, that's cool. Man, that is too cool. All right, so now that we know that it works, let's go ahead and button all this up back down inside, and then we can do an official little reveal of this. All right, now when you have your watch and you have the centerpiece here, this T is gonna go here at the front. So you're gonna make that where the front of your watch is at. And then you're gonna go ahead and spin the dial inside until this reaches where it needs to be. Right about there, as big as mine will get. So I can then take this, place it on here, and now we can watch it turn. Well, that's it, guys. This was a super awesome, fun project. I am glad that I can now have my watch be wound when I don't need to wear it. Again, this turns 30 times 15 in either direction every hour. So it will turn 30 times, rest an hour, and then rinse and repeat, returns to the same position every time. One thing I do want to add is that I did find another wiring diagram for this. It uses a momentary switch instead of a latching switch like this one does. And if you want to use that, you can. It does rotate a little more frequently over a period of time. This one rotates, basically once every hour or 30 minutes, however you set it in the code. The other one rotates a little more often. I like the way that one works as well. It runs the mode a little bit better. Not my code at all, but I did make a few small tweaks to it to make it just, what I think is the best way. So you can find links for that down in the video description. And yeah, again, a great project. Took about 10 to 12 hours to print all the parts, but an hour here to assemble everything. Not too bad at all. A little bit of electronics work. It's a very easy beginner project if you want to check it out. So if you do want to download this and try it out, there will be a link down below where you can get it. Also be details down there for the first few of you that can actually go ahead and get this for free, 100% free. It's on Cults 3D, so check that out. It's me again. So if you want to win this, make sure you look below in the video description. There's going to be a link to my Twitter, and there's going to be a tweet that you need to comment on. The first 5 people to comment on that tweet are going to get this for free. Make sure you follow me so I can follow you back, and then you're going to need to DM me your email address so that I can send it to Cults, and then Cults can add it to your account. You also obviously have to have a Cults 3D account, but I'll put all the details below. But yeah, comment on there. First 5 people get it for free. Continuing on. Or throw I think it was about $1.90 something for this to the actual creator and try it out yourself. I'll also link all of the electronics you're going to need, the tools you're going to need, the parts you're going to need. Everything will be linked in the video description, so be sure to check all that out. Thanks for watching, guys. I hope you enjoyed this content. If you did, please give it a big thumbs up. If you didn't, thumbs down. Talk to me down in the comments below and let me know how I can improve my videos. If you guys want to stay tuned what's going on and be notified when these awesome projects happen, you need to be a subscriber. So hit that subscribe button and then hit the bell icon. That way you get an email notification or a push notification when I upload new content or do any live streams. If you want to help me out, support to do what it is that I do, consider becoming a patron. It only takes $1 to get access to my Patreon feed and the after show. The link for that is down below. Other ways you can help out, one-time donation links are down there, or use some of the affiliate links and the coupon codes down there. Save yourself some money, and a little slice of what you buy comes back here to the channel to help me to buy new things for my channel. I thank you guys for tuning in, and until next time, happy printing.